everyone. Thank you so much for joining us today for a discussion on designing the best cloud architecture for your org. This is a LeadDev webinar created in partnership with Do It and AMD. Logistically, the webinar will last roughly 45 minutes, after which both myself and the panelists will head over to the LeadDev Slack channel to answer some of your questions in the scaling channel. We may also have time to answer questions live, so please do submit questions through the Q&A feature on Zoom, and we'll get to them if we can towards the end. So let's get started with some introductions. My name is Tanu. I lead enterprise architecture strategy at Capital One, and I've had the pleasure of dabbling in cloud architecture in my career. Today, I'll be joined by several esteemed colleagues, and I'd like each of them to share their experiences and insights through our panel discussion. And first, I'll ask each of you to introduce yourselves, starting with Fagani.
Hello everyone. I'm Fagani. I'm working as engineering lead for a company named DataRobot. I'm leading a team which we are working on building Kubernetes platform on multi-cloud, like most of the known cloud providers. I have been part of different great teams in my experience, which we built it and architected cloud platforms for different reasons, for different user audience. And yeah, in my free time, I'm also advocating for clean cloud by talking in conferences, in local events. Yeah, that's me.
Thank you, Fagani. Next up, we have Keisha.
Hello, everyone. My name is Keisha Williams. I've been in tech for about 28 years, and every time I say that, I just can't believe I'm that old. I started my journey in web development, the Java software engineering space. Many years ago, I transitioned to the cloud and AWS, and then to AI and machine learning, just really continuing to grow my technical skills over the years. I've worked in many industries: hospitality, healthcare, airlines. Today, I work for a company called Slalom. I'm a director there, leading a team of cloud engineers. At Slalom, we just help organizations write better software, migrate to the cloud, modernize their architecture. I'm also just very active in the community by speaking at conferences, writing blog posts, authoring courses. So I'm just happy to be here today.
Thank you, Keisha. And next up, we've got Mike.
Hello, everyone. I'm Mike Spar. I'm based in Missoula, Montana. And similar to Keisha, I've got a long history spanning back from the late 90s, leading software development, web development for ISP, worked at Accenture, led projects overseas and here in the United States, and then 17 years of building and leading SaaS-based software startups. And the past couple have led me to this journey on the cloud, either consolidating companies and roll-ups, or previous company migrating from traditional data center to cloud. And then now I'm working for Do It International, where I used to be a customer, and it's one of the largest global MSP providers for Google, and also rapidly growing on AWS, originally founded in Israel. So it's great to be here and great to meet you all.
Thank you, Mike. And Clint.
And good morning. I'm not sitting in as near a lovely place as Montana. Forgive me as I'm sitting in a hotel room, unfortunately, in Las Vegas right now at a show. But thank you all for having me. My brief history, as you can tell, is probably not as brief, but been hanging around IT for the last 30 plus years. I started my career, unlike most of the folks here, I started on the infrastructure side, building and running very large data centers for large chemical companies. Went on to Microsoft to build out data centers back in the late 90s and early 2000s. But as a infrastructure professional pre-cloud. One of the things that we really focused on was the fact that we needed end-to-end service quality, and to not just think of individual components, but think about the service. And obviously, cloud has brought that to the front. My passion drove me to go do a startup, and that startup itself it came out as a product called Cloud QoS, and developed that from 2013 through 2019. And oddly enough, most of my customers were the clouds themselves, cloud providers. And now I'm over at AMD, driving ecosystem engineering, solution engineering, and partnering very, very closely with a lot of the SIs and CSP service providers out there. So again, super excited to have this conversation.
Thank you, Clint, and thank you to all of our panelists for introducing yourselves. I'm taken aback by the tremendous amount of expertise and journeys that you have taken in your careers. Speaking of journeys, cloud itself, I think, is considered a massive inflection point in the journey of technology evolution. We are now at the dawn of another one with AI ML. And I think some of you even mentioned AI ML as something that you're looking at in your day-to-day jobs. The first question is, how is AI ML changing how we think about cloud architecture and running workloads in the cloud? I'd love to hear everyone's take on this, starting with Clint.
You. So what's really interesting, and as I shared a moment ago, I really think in patterns, and most of us have had to think about patterns and workloads, because it's hard to think when you're, depending on who you listen to and which agency, there's something in the neighborhood of just over 500 million instances out there, workloads running. And the ability to think about 500 million, you need to be able to think about how do I take those patterns, how do I understand those patterns, and the placement of those patterns, and where better does the AI ML analysis really help us come back and understand the matching of what is the right platform for the right workload, right? And we'll take obviously most cloud providers, AWS, GCP, Azure, and obviously just a host of tier twos that are out there that are really meeting the need. How do I understand those workload and those workload patterns? So one of the things that we're doing very heavily is doing a lot more workload profiling, and helping actually share that workload profile for the AMD instance types back with the Solomons of the world, and a lot of the various providers. And so the AI ML analysis and taking all that big data has been really a big key, because what we're finding is the customers know the potential, but they're looking for us in the IT industry to really help them take that knowledge, that data, that complex mathematics, and make it much simpler, because they see it in their everyday lives and they know it should be simplifying both placement and continuous placement in the cloud. Just a couple of thoughts there.
Thank you, Clint. Next up, I'd love to hear, Mike, your point of view on this question of how is AI ML changing how we think about cloud architecture and running workloads in the cloud?
Well, I guess you could attack this from many angles, either just running AI workloads on the cloud itself, or leveraging AI technology to optimize how you operate day to day. I've seen two distinct areas. One of them, like Clint mentioned, I think it was interesting that he mentioned that he kind of looked at infrastructure as opposed to the components, but as an overall service. And that service view, which the clouds have kind of almost commoditized now, means that most of the challenge in an organization is familiarity. And so when somebody's adopting cloud technology, oftentimes it's whatever they're familiar with, because each provider now is offering almost all the same services. Azure and ChatGPT are definitely a key differentiator that's raising some eyebrows. But at the end of the day, if somebody's familiar with one cloud, they're probably going to recommend that or try to implement that at their company, and the rest is pretty much commoditized. So where I see AI being adopted, number one, is on the support side to skill up the team. We're seeing, I just got back from Google Cloud Next a couple of weeks ago, and there was a big push for the AI integration into Workspace and into Google Cloud with their Duet AI. And so pretty soon, these automated recommendations and workload right sizing are just built right into the cloud consoles themselves to help improve day-to-day usage of cloud technology. I think the other, and along the analytics side that Clint mentioned, the FinOps Foundation is gaining a lot of momentum in the industry, and FinOps has some prescribed practices like automation of chargebacks and getting your cloud costs standardized across all providers and focus on unit economics. And I do think that the AI is going to automate a lot of the analytics of this cost information to try to make it more affordable to run workloads or more predictable to run workloads on the cloud. So I would say forecasting and cost optimization, but then also augmenting the team's skill sets on whatever the cloud they are on to help them right size their workloads.
Thank you, Mike. So far, I think what I'm taking away is we can think about opportunities to apply AI and ML in terms of workload sizing, workload placement, the actual profiling of the workloads, but also the talent that's deploying the workloads to upskill that talent. Keisha, what would you add?
I absolutely love this question. As an AWS machine learning hero, I'm always out just evangelizing AI and ML, and I'm just really excited about the impact the technology is having. And when I think about this question, though, I approach it from the modernization and migration to the cloud, because that's a lot of what my team is responsible for, and just thinking through how AI can help us with that. And I was just literally having this conversation with a colleague the other day, just brainstorming and thinking through how we can start to use AI and ML more as we're modernizing and migrating applications. And there are ML tools out there that help to automate from a refactoring angle, from a replatforming angle, like taking a legacy code base, COBOL, and converting it to Java. Of course, we still need to have eyes on that Java code to make sure that it's optimized and efficient, but just using those ML tools can give us this huge jump start with migrating these legacy code bases. AWS has a tool called Blue Age, which is on my to-do list to start playing around with and just learning more about that tool and how we can use it. But to the original question, I think Mike and Clint covered it really well, from just like workload profiling, optimizing workloads. And then from a security perspective, there are a lot of AI and ML tools that help with threat detection, automating operations, help with forecasting and capacity planning. I think we've only started to touch the surface of how AI and ML can help in all of these areas.
Thank you, Keisha. So not just the operational opportunities like FinOps and things like that, or migration of workloads, but also the security opportunities of enhancing the security of those workloads. Pagani, what are your thoughts around this?
Yeah, so as Mike mentioned, we can attack, or we can approach to this question from different angles. But as an engineer coming from a background that always been there to design these cloud architectures or services for developers to run their services, provide software solution services to customers, we have different frameworks from cloud providers, like they call them sometimes well-architected frameworks, and it touches to different points like operational excellence, sustainability, security, cost effectiveness, and all these topics. So the tools we use daily, like almost became the standards in our world, like Terraform, like tools for monitoring our costs in our cloud environments. the tools provided by the cloud providers themselves, not the third-party ones, all of those are getting support from AI. Like we are able to easily generate boilerplate codes. We are able to use generative AI to generate some, starting points or some general ideas about what should we consider while designing our cloud architectures. So this is definitely helpful. This becomes a sort of new abstraction level for us as a developers, as an engineers. We can use and start building our services on cloud. This still requires a great experience from engineers to review those architectures, to actually plan for scalability and for future, but still being able to use generative AI to generate those faster and use the features to get some ideas how we can reduce cost, how we can switch to the better instance types, for example, to save more, to have better utilization. So I see a lot of opportunity there from especially generative AI.
Thank you, Fagani. So what I'm hearing is generative AI has a huge potential to accelerate the things that we need to do to be able to use cloud effectively and operate there. Speaking of operating effectively on the cloud, the next question is, what challenges did you experience in architecting for the cloud to support cost-effective, easy-to-use, yet complex workloads? I'd like to start with Fagani on that. What challenges did you experience and how did you overcome them?
Yeah, so this actually we can continue from what I mentioned just before. Like when you want to architect in cloud, those things comes to your list, like operational excellence, cost effectiveness, easy to use. All these things come to you and you have to architect and design for that. But it's not easy as you think first. When you think about it, okay, you can design a great cloud architecture that can be cost effective and everything, but every day something changes. You have a new requirement, you have a new workload running, and making this cost effective, always being on top of the things, seeing the future is not easy. So that's one of the main challenges, for example, like to stay cost effective while the requirements change, while you have new services to run and all this stuff. On top of that, like keeping the operational excellence, like knowing that what changed when and how to immediately revert back or how to immediately apply fixes for customers, for your cloud workloads, for the services running on your cloud environments. Those are like the biggest challenges you can experience while architecting for the cloud. Because if you don't consider the cost, for example, the day becomes that actually you are spending more money on what you are getting than on cloud providers. So that's why I believe actually the major cloud providers are doing great job and they are helping with their tools. For example, AWS has the integrated cost analyzer and different services that you can see which kind of actions you can take to improve your cost effectiveness, to improve your security and all those things. So those are the main challenges, and I'm very happy that cloud providers are offering new solutions every day to us to use this. And I believe, we all cloud architects and engineers should benefit from this and work together with cloud providers to have a clean cloud instead of running, a lot of services that don't utilize properly and, we spend money on more than we should.
Thank you, Fagani. So I think what I heard from your response there is cloud architecture, cloud design is not a once and done thing. You really do have to make an effort to stay on top of the new services, the cost levers, and make an effort to stay optimized more than just day one. Keisha, what is your perspective on challenges and how you overcame them?
Sure. I can think of so many challenges. I don't even know where to start, but one that's really been top of mind for me lately centers around unforeseen dependencies. And like I mentioned, my team is mainly responsible for migrating and modernizing workloads. And typically organizations have this end goal to have all of their applications migrated and running in the cloud, and not just a simple lift and shift, but a re-architecture to really take advantage of what the cloud has to offer. And that in itself is a journey. It's not something that happens overnight. Typically, we'll start with a lift and shift, and then we'll re-architect applications over time. And that sounds simple. You're just going to lift it and shift it. But like Fagani mentioned, workloads always tend to be more complex than you originally imagined, especially when you're migrating like mainframe applications. It's just so important to really work hard to identify dependencies up front, determining if those dependencies go or stay, figuring out how you manage communication and data movement. And that just makes the architecting and the architecture even more complex. I remember on a project that I was on, we did a lift and shift, and we were testing, and this unforeseen dependency popped up. So there's this one system that's been running on the mainframe, moving data here, moving data there. No one really understands why it's doing that, but it's just been running for years, and it just runs. And when you uncover things like that, like I mentioned, it just makes your architecture more complex. It drives up costs because now you have to build ways to keep the data in sync. You can't truly migrate the entire application. Now you have to flip to sort of this hybrid architecture, and it just really makes things more complex. And so my advice there, just always make sure you understand the dependencies up front and you have a plan in place to help the applications finally be fully running on the cloud and not have ties back to on-prem. So dependencies, unforeseen dependencies, that's a big challenge.
Thank you, Keisha. That definitely resonates with me. And I think the key takeaway there is when you're thinking about migrating to the cloud, it really isn't as simple as one workload at a time, because really what you're doing is you're transitioning an entire ecosystem. And so uncovering those dependencies up front allow you to provide a stronger architecture and migration plan overall. Awesome point. Mike, I'd love to hear your take next.
Well, I've got a couple of viewpoints, obviously, from previous companies, challenges that we face, but then also now working at DoIT, we serve I think over 3,000 companies worldwide and support them in their cloud journeys. And so I see a lot of common patterns in these challenges. But I think first and foremost, and I think this is where I was actually attracted to DoIT as a customer in the past, is skilling up the team. Because if you're leveraging cloud technology, the first thing you need to know is what services and resources are available and what the best practices are. And so oftentimes staying current on that when you're focused on serving your customers is a challenge. So if you have a team that's there to support you, that their job is to stay current on these things so your team can focus on delivering value to your customers, then it's a win-win. And I think that's what attracted me to DoIT, coming from being a customer and then now actually working for the company. And so I think the main challenge is skilling up the team. And in every previous company, that was job number one. Once they were familiar with the platforms, then like Keisha said, actually coming up with a plan and taking inventory of what you currently have, and then prioritizing what you need to migrate and in what order. And that prioritization is often difficult, but usually it's find some vertical slice in your technology stack that you could migrate independently and use that as an opportunity to skill up the team and work out any kinks, and then progressively start to move additional workloads over. But aside from skilling up the team and being familiar with best practices on the cloud, I would say the next challenge that was brought up, like Fagani, is cost management, cost control. So if you understand those cost levers, for instance, there's a lot of services that are serverless, but once you choose them, if you haven't planned for the actual workload or the resource consumption, that can bury you or bury your company. An example is if a system needs a constant uptime, constant workload, but somebody goes serverless. Serverless is great for these burstable, auto scale solutions, but if you had a constant workload needs to be running all the time, you're going to be spending considerably more on your cloud bill for those. And so it might be better to move over to a container orchestration platform and just pay for the compute infrastructure for the node pools. So thinking about those things, I think, is the next challenge, is understanding the actual cost drivers to be able to design the architecture. And then specific challenges, ironically, our company also provides a FinOps dashboard. Kind of like Fagani mentioned, the tooling that each cloud vendor provides helps you optimize your usage of the cloud or monitor your spend. But a lot of companies these days are spread across multiple clouds, either through M&A or to hedge their investment in cloud or give them leverage in negotiating prices. And so each individual cloud provider is not incentivized to provide you a single pane of glass dashboard to be able to view all your spend and analyze your costs. And that was something that we recognize. And so we actually built a multi-cloud console that adds that single pane of glass of all your cloud spend across multiple clouds and standardizes those unit economics, allows you to attribute costs to the team, and then also includes anomaly detection back to the AI/ML discussion and forecasting. And so by doing that, I'd say it kind of helps solve a lot of those challenges. But our team uses cloud for running our software platform. And just recently, we've gone through a cost optimization exercise. And I think I saw the last report, and over the past 5 months, they've shaved $15,000 a month off of their cloud spend. And I think 3 of like the 6 solutions were just cloud storage and logging and log retention. So simple stuff that people don't think about, storage, lifecycle plans, and log retention contribute a huge factor to cloud success. So.
Thank you, Mike. So I heard a couple of great nuggets of information from your response. One was, don't forget to upskill your humans.
Yes.
Because the humans need to be trained to be able to make thoughtful architecture decisions for the cloud architected workloads. One of them certainly being around costs and cost levers. So not just saying, let's do serverless because serverless is really cool, but being really thoughtful based on the workload characteristics to find the right computing runtime environment. And also having the transparency and insights to be able to do things like cost optimization over time, to Fagani's earlier point of, hey, things are always changing. You have to stay on top of it. Thank you for that, Mike. Clint,
Thank you.
What is your perspective on challenges?
Yeah, I was going to say the team's already covered, obviously, a huge breadth of challenges. The really interesting thing is the one thing that all of this really points to is setting and meeting expectations. And the cloud migrations that I've led in the past, the understanding of this, and I think everyone touched on it here, and Mike to even a greater extent in the last few minutes, is the fact that setting and meeting expectations is critical. And that isn't just a technical, that's really a technical in the business, and it's managing the expectations throughout that life cycle, whether you're doing a refactoring, whether you're doing a lift and shift, whether you're doing a new development. And what's really interesting is we're seeing a lot more accountability in the industry and expectations of visibility of, okay, I'm going to set this expectation today, and 2 years from now when we're done, I want to know that I hit that. And yet we all know that IT is dynamic. The workloads are dynamic. The expectations of people are dynamic. And so what's really interesting is managing those expectations, setting and managing them and tracking them over time so that as things change, that you really have the ability to look at that. That has become, I would say that's one thing that while all these other things are super critical, it's one dimension that wasn't talked about. So I think it's incredibly important to call out. That you are going to be held to whatever you committed to, even though the world changed between the time when you did the commitment and when you delivered. And so thinking about that, knowing that by nature is a super critical piece that you need to do throughout that process.
That's so important, Clint. And you're right that it may not be an intuitive thing when you're thinking about cloud architecture, but it is such an important thing that the architecture that you're delivering, it is based on a business need, and you have to be able to set the right expectations to fulfill that business need. Just
and sorry, I'm just going to add, and the business need is changing over the time in which you're actually building it.
Right, and that change factor again, keeping up with that. So just a reminder to the audience, if you do have questions, please feel free to enter them into the Q&A Zoom feature so that if we have a few minutes, we can address questions live. Speaking of questions, so we talked a little bit about technology evolution. Mike, you mentioned multi-cloud a little bit earlier in one of your comments. I'm curious to hear your perspective on how is the evolution of IaaS, PaaS, and SaaS services affecting cloud architecture strategy? And is there a benefit in a multi-cloud strategy? Keisha, if you could take that one first, we'd love to hear your thoughts.
Sure. When I think about the evolution, and like Mike mentioned, the evolution, like we're starting to see more multi-cloud and hybrid cloud architectures. I believe it was Gartner that threw out a number that 75% of organizations that have adopted the cloud also adopt this multi-cloud strategy. And so that says to me that that's a pattern that we all need to start thinking about and potentially start recommending to our clients and the people that we work with. 75% is a huge number. And when I think about multi-cloud, there are a lot of benefits, better user experiences, enhanced resiliency. There are some challenges. It makes the cloud architecture more complex. You're having to manage and integrate services across different platforms. I was really impressed by Mike talking about that one pane of glass application that his company developed that allows you to see your spend across all of the different clouds. That is a huge, huge win. And also, when we think about the evolution with the cloud architecture, we're starting to see more, microservices, containerization, automation around infrastructure as code, just all of the common things and a lot of the buzzwords that people have been talking about lately because it brings so much benefit.
Thank you, Keisha. Mike, would you like to go next?
Well, sure, thank you. And thanks for the shout out, Keisha. And kind of remind me on the specific question, just so I don't go awry, about multi-cloud.
Sure. So it's a two-part question. How are you thinking about the evolution of IaaS, PaaS, and SaaS affecting cloud architecture? And similarly, another thing that could affect cloud architecture is multi-cloud. Do you see benefit in a multi-cloud strategy?
Okay. So the IaaS, PaaS, et cetera, I think, and I don't want to steal anybody's thunder on this, but I think oftentimes that decision often gets into a vendor lock-in type decision process. And so there might be teams that want to get up to speed quickly, and I see oftentimes the like the platform as a service solutions, usually for digital natives. That's an easy get to market quickly solution, and then later as they scale out, they start weighing the cost benefits, or if they migrate to other providers, then they try to look for something a little bit more platform agnostic. And so I think leading into the multi-cloud, what we've seen is this trend. We've been around long enough. We've seen these cycles over and over again, and it's like build once, run anywhere, and that keeps coming up in different technologies and different platforms. So now it's containers running atop Kubernetes, and so I think some of these platforms as a service are becoming commoditized, and companies are leaning towards container-based workloads running atop Kubernetes for orchestration, and then seeing whether or not they can distribute Kubernetes clusters across multiple clouds, but still have to tie in the networking and the security atop that. And that's a challenge where service meshes have kind of come into play. And so you've got Linkerd and Istio, or the cloud vendor specific service meshes, to solve those problems at that abstracted layer. And that's the enabler for this multi-cloud future. So I kind of see, like, I know with Google, App Engine was kind of their crown jewel, and it was very prescriptive in how you would architect applications. Then AWS became very popular with Lambda, and then there's Firebase and Amplify and other solutions specific for mobile startups. And so I see a lot of those that are adopted by digital natives in early stage, and then later as they mature, they start to build out their own solutions, containerize their applications, and orchestrate them across Kubernetes. And so even Amazon themselves used their own serverless infrastructure. And then there was the famous post, I think a few months ago, that one of their teams for one of their products switched to just running on compute instances or virtual machines, and saved significant amount of money and increased performance of their system. So I think there's a buzz and there's an allure and there's a specific use case for some of those workloads. And then as companies mature, they are moving more towards container-based workloads run across an orchestration platform. So that's kind of what I'm seeing.
Thanks, Mike. So I'm hearing that perhaps an architecture principle would be that build once, run anywhere kind of principle. Clint, what is your perspective?
I agree with everything Mike said. That everybody has been trying to get the build once, run anywhere forever. And I, by the way, I had to laugh when Keisha talked about COBOL and mainframe, because I will simply say I go back to many of those days. But different conversation. What's really more interesting to the point on multi-cloud hybrid, we are going to live in, whether we like it or not, we're living in a multi-cloud hybrid services model. And customers are really looking for their workload, whether it is a service workload, whether it's a traditional workload, whether it's a migrated workload, whether it's an old COBOL, just containerized and dropped somewhere. They have to really think in a world in which they're living in bare metal, cloud, container, and candidly virtual. And so understanding that, and while we all will end up, and we see most customers moving to, okay, I'm going to put most of my crown jewels in one. And back to Mike's point, right? You don't want to get into vendor lock-in, and both for financial and other reasons, not all cloud providers have the right and perfect services for each application either. And so what's really interesting, we look at GCP and the high performance compute, great example. They've made huge investments in that. While there's a lot of AWS catch up there, being quite candid, that you don't see a lot of Azure there, right? So the reality is this is happening. And so the management layer, and again, a single pane of glass, as Mike called it a moment ago, the management layer from both the financial, operational supportability is the real key there. And so to think that you can live in all IaaS on one cloud or all microservices on a different cloud, while it's ideal in a perfect world, none of us live in IT in a perfect world.
Thank you, Clint. And Fagani, if you want to round us out, what's your perspective on the evolution of IaaS past SaaS and potentially multi-cloud strategy?
Yeah, sure. So if we start with the first point of the question, like how is the evolution of infrastructure as a service, software as a service, and platform as a service affects how it works? So here's the thing, we can approach from two perspectives. Let's imagine that we are a single developer or a small startup that you don't want to deal with all infrastructure problems, provisioning infrastructures, and so on. But you have a Python code, for example, you use the Cloud Run service from Google Cloud, just an example, alternatives from other cloud services. So you get the platform as a service from them, you put your code there, and the cloud provider handles everything for that. You don't worry about the infrastructure, you just update your code. They are doing the security patches, they are upgrading the underlying infrastructure, and you are on the market already. But when you're a big company, like I am working for right now, and you have different, like more than 20 development teams, they are building different microservices, and you want to provide an internal platform to them, then you go to AWS, for example, or any other cloud provider. You either build your virtual machines and you manage the Kubernetes clusters by yourself and provide it to your developers, or additionally use the platform as a service like Amazon EKS or Google GKE from the cloud provider, and you actually build something on top of it. You deploy the tools your developers need on top of it, the monitoring your developers you need on top of it, then provide this as an internal platform to your developers. Then when all developers, all different application teams deploying their services there, you just provide this as a software as a solution to your customers. So all of this is already integrated to each other and bounded to each other a lot. And for example, like if you check AWS, they're offering AWS SaaS Factory, which they are helping you with reviewing your resources you are using from that cloud provider. They are providing you some help with getting cost effective, getting ready for production workloads, and they are verifying that, okay, you are ready to offer a software as a solution service to your customers in AWS. And I'm pretty sure other cloud providers also have similar solutions like AWS SaaS Factory. So that's how I see in general, like infrastructure service, software as a service, and platform as a service evolves and how it gets integrated to each other. And if we go back to the second point, the multi-cloud strategy, there are definitely a lot of benefit. So the first thing on that is, like, you may have customer which wants even they are using SaaS service, they want their workload to be in specific cloud provider. So then you are able to offer, for example, the service you're providing in the cloud provider your customer wants. Or the second option is when you have a free option to choose, for example, to run the managed Kubernetes cluster, you may want to choose the Google Cloud one because they are offering autopilot in GKE and they are offering most of the tooling coming with the cluster already. So you don't have to install, for example, Nginx Ingress on top of that. You just have it ready already in that managed cluster. And yeah, when it comes to, for example, offering a serverless solution, you may think about, okay, AWS Lambda has some things that works best for you than Google Cloud or Azure or any other provider. Then you choose to run that specific service on that cloud. And you can also include the pricing there because different cloud providers offering different pricing model for their services. So you can choose the best pricing model for you and save them out of money there and go with that. So those are the main things coming to my mind, but I am pretty sure we can add much more to this list.
Yes, thank you, Fagani, I think. Oh, go ahead, Mike.
Oh, I would say the one thing to be weary of is the networking costs that kind of trip people up. So if you are using multi-cloud and you have one service depending on another service, another cloud, sometimes the egress costs of that access or the VPN or interconnect costs don't justify the gain in that service. So that's where you need to make those decisions, and then also skilling up the team and securing those workloads and having the expertise to secure them on multiple platforms. So those are considerations that we have to consider, of course.
Absolutely. Well, this was a very meaty topic, and I'm a little sad that we're actually at the end of our time. I did see one question from the audience. Appreciate that question. We will move this conversation over to Slack in the LeadDev Slack to the scaling channel so that we can spend a few minutes answering the audience question as well as any other questions the audience may have. Really appreciate the audience's time today. Really appreciate the time of our panelists to give us their perspectives and learnings from their experience. This was really fun for me, and I learned a lot, and I hope you did too. Thank you.